Now, a big part of what we're doing, as you might have picked up, is looking at perfect squares. So knowing our perfect squares is going to be very useful for what we're doing here. Now I have the square root of 24, and I want to simplify this radical. To simplify the radical, I want to look for the largest perfect squares that I can remove, or that I can split this up into. So I can remove the perfect squares from under the radical. So I look at the factors of 24. I have 1 and 24, I have 2 and 12, I have 3 and 8, and I have 4 and 6. These are my factors of 24. And the only ones that have a perfect square are 4 and 6, because 4 is a perfect square. Since 4 is a perfect square, I want to split this radical into two separate radicals using these two factors. That means I'll split the square root of 24 into the square root of 4 times the square root of 6. That product property tells me that I can do that. I can split the fraction into, or the 24 into two separate radicals. And of course, the square root of 4 we know is 2. The square root of 6 can't be split into any other perfect squares. And as long as we find the largest perfect square that this product contains, we will never be able to pull another perfect square out. Since 4 was the largest perfect square factor of 24, I knew that 6 could not contain another perfect square, because if it did, then 4 was not the largest perfect square we could separate it into. That means my final answer is 2 times the square root of 6. Now I have a little bit different direction here. I have the square root of 5 times the square root of 18. And what I want to do in this case is not look at each one individually. That would take too long. Instead, I'm going to multiply the two together and see what I can do with that. So I multiply 5 times 18 because the product property says that since I can pull them apart, I can pull apart some product to get 5 and 18. I could also smush them together to get a whole number, a regular number. So if I multiply them, they would sit under one radical. 5 times 18 is 90. So the square root of 5 times the square root of 18 is the same thing as the square root of 90. It's that product property, just going in the other direction. Now, 90, it might be pretty obvious what we're going to use, but let's look through our factors anyway. I have 1 and 90, 2 and 45, 3 and 30. I have, let's see, 4, it doesn't divide by 4, 5 and 18, obviously, and I think 6 and 15, and 9 and 10. So I look at my factors here. The biggest perfect square factor that I've got is 9. Since 9 is the biggest perfect square factor, I want to split the square root of 90 into 9 times 10. So that's what I'm going to do. I will have the square root of 9 times the square root of 10. And of course, the square root of 9, we shall be aware, is 3. So the square root of 9 becomes 3. The square root of 10, I know it doesn't contain any perfect square factors, so this is my simplified radical. Okay? Now, I have the square root of 9 over 64. And the quotient property says that I can split this fraction into two radicals, and that's what I'm going to do. I'll take the number on top becomes its own radical, the number on bottom becomes its own radical. That means instead of the square root of 9 over 64, I have the square root of 9 over the square root of 64. And that's easier to deal with because the square root of 9 is 3. The square root of 64 is 8, which makes my final answer 3 over 8.